Hello, my name is Rael Khan. I'll be speaking today about meditation and the neurophysiology of self. I'm a psychiatrist and neuroscientist working at the Department of Psychiatry, University of Southern California in Los Angeles. So to start with, just a few words about the traditional Buddhist view of the self. As many of the audience will probably know, maybe in more detail than I do, there are many essential teachings in Buddhism about the self and its relative illusory appearance for humankind. In fact, one of the many lists within Buddhism's like the Four Noble Truths, the Eightfold Path, are the three marks of existence. Three marks of existence traditionally being taught to be impermanence, selflessness, and unsatisfactoriness. So one of the most fundamental markers of existence is that the self that we experience is essentially empty, an illusion, and that the belief in a solid and stable self actually leads to suffering, and that it's possible to realize the emptiness of self through mindfulness and meditation. In the modern psychological sciences, we have come to conceptualize the self as a kind of nested hierarchy of levels, from a kind of a proto-self, the moment-to-moment representation of the bodily state, to a core perspectival self, the kind of transient sense of perspective that's present in the here and now, which does have a kind of object-subject-object duality to it. And then the bodily self, the sense of actually a kind of ownership of the bodily experience. And then at the kind of highest level, this autobiographical or narrative self, the narrative timeline of who I am, that involves memory and a sense of identifying all these characteristics, the kind of me relationship to self that is characterized by a bunch of beliefs about what I am and what I am not. And of course, what we've come to realize, speaking more as a clinician, is that threats to the narrative self are a central element to the experience of stress. So, of course, if our bodily self is threatened by some physical danger, we experience stress, and that's how stress evolves within the animal kingdom. But as we human beings have come to identify more and more, not just with the body, but also with the narrative self, anything that threatens our sense of who we believe ourselves to be, or what our sense of meanness encompass, is also experienced as a threat, and experience includes a lot of the same stress responses that are oftentimes quite inappropriate, given that there's no actual physical danger to the body, but the body will start protecting itself and acting as if it's in physical danger because of this kind of hierarchy of selves being kind of mapped onto one brain. And indeed, unconstrained self-focused rumination is a very characteristic aspect of many forms of suffering that we have different names for within psychiatry, whether they be the anxiety disorders like generalized anxiety disorder, the depressive disorders like major depressive disorder. There's oftentimes a common theme that runs through them of kind of not being able to stop thinking in a self-referential way. And of course, another danger of identifying with the narrative self may very well be that it's just a disconnection from reality. Certainly within the Buddhist teaching, one would say that. And when kind of delving down into what is the narrative self really composed of and what is its meaning, using a scientific approach, it's actually pretty hard to find something real there, other than just a construction that we make real for ourselves. So interestingly enough, the use of mindfulness within a secular clinical perspective, which is a marker of many of the more recent developed forms of approaches to psychotherapy, is that by helping people to decenter from the identification with their thinking and their sense of self-related processes, we are able to help them experience a much greater sense of flexibility and well-being. And so, although secular mindfulness is different from mindfulness as taught within some of the different Buddhist traditions, there is this kind of overlap with the psychological process of becoming less identified with the thinking that goes on moment to moment, and a lot of that thinking has to do with the representation or experience of a narrative self. So getting into some of the neuroscience, what have we in neuroscience been doing in regards to measuring the self? And there are a lot of ideas about the self, philosophically, psychologically, and of course that translates into what neuroscientists have been trying to do. In the end, because of this very slippery construct and that there are multiple levels, there's likely no single neural substrate of self. However, there certainly does seem to be a transformation of the experience of self that people experience through different forms of human teaching and learning and practice. And certainly meditative practices are quite powerful in regards to the experience of self changing. So to kind of start with some of the basic neuroscience investigations of self, this is just a summary from a review paper about 15 years ago, wherein they looked at many studies that had been done using fMRI up to that point, trying to distinguish between self-related processing and other related processing, and finding that it's these areas along the central midline that seem to be quite involved from study to study, oftentimes either the frontal or the posterior, but in the midline areas, and more often frontal than posterior. And it turns out that those are two of the central areas of what we now call the default mode network, the posterior cingulate cortex, or precuneus in the posterior areas, and the medial prefrontal cortex in the anterior areas of the midline. And of course, there's also the temporal parietal junction, or the infraparietal lobe. Those are the three primary circuits that make up what we now call the default mode network. There's also some contribution of the temporal cortex. And many people have heard this name by now. It's become quite well referenced, and sometimes over-referenced and kind of taken to mean what somebody wants it to mean. But it does certainly correspond to something real about the way the brain functions. These are areas that are more active when we are not specifically engaged in a task than when we are. And they kind of are the default areas that become active when we don't have something specifically that we're doing. And of course, they are active in concert, and or different elements of these circuits are active in concert with some tasks as well, but they especially become active when we stop kind of orienting towards a task. And what are we doing in our default state when we're not kind of engaging in tasks? Well, a lot of what we're doing is something we now call mind wandering, just kind of having the mind go from here to there, and could be moving in time from past to future, imagining, planning, incorporating memories, reflecting. one of the things that's definitely true about this baseline state of ours is that it tends to be about the self, me. And so the notion that some of these areas are what has shown up across many studies over time as kind of specific to self-related processes is not really unexpected now that we know this distinction about the default mode network and narrative thinking. So we can kind of overview the state that the narrative self in particular does seem to be somewhat specified by the default mode network, especially some of the frontal areas. And it also turns out that the default mode network is highly implicated in one of the most frequently and strongly affected set of circuits affected by meditative practice. So the first demonstration of a kind of state and trait related effect of the default mode network was demonstrated by Judd Brewer and colleagues back in 2011, and really looking back previous to that, and then certainly prospectively since that time, quite a large percentage of fMRI studies have localized kind of significant changes related to either novice practice, beginning to practice, or long-term practitioners, as something about differential engagement of the default mode network. In particular, the tendency is that the more one becomes skilled with meditative practice, the more capacity one's brain shows to fluctuate up, like essentially turn off and on, relatively engage, disengage the default mode network in association with something around narrative processing and self-related processing. Now, in order to really get into the details of the self-experience and brain, we have to become a lot more fine-grained than just looking at average brain scans when people are meditating or not, and start probing into moment to moment the experience of self, because it really is a fluctuating, fine-grained aspect of experience, as anyone with meditation practice will be quite familiar with. And so approaching brain states in a way that allows for quite tight coupling between subjective reports of internal experience and the objective measures of the brain is really necessary. Some of these approaches related to self don't involve meditators. Of course, everyone has a sense of self, and so you can probe anybody with these kinds of approaches. Catherine Tellam-Badri and colleagues published a very interesting study looking at the relative amplitude of the heartbeat evoked potential, the degree to which the brain is responding to each and every heartbeat, and probing into whether the amplitude of the heartbeat evoked potential might be correlated with something around self-related processes in spontaneous mental states. So they probed people intermittently as they were in this case, an MEG. And what they found was that when people reported that their mentation just prior to the probe was me related, so thinking about something about themselves, some characteristic or some kind of thinking of themselves in that objective way, like me, they were much more likely to have increased heartbeat evoked potential amplitude in the medial prefrontal cortex, this kind of frontal aspect of the default mode network. Whereas in those cases when they reported a lot of I-related self content to their thinking, so we're thinking not about the future generally, but their own role in the future, or very much a perspective from the sense of themselves looking at the world. Those reports that were higher in the I dimension compared to low tended to be associated with increased amplitude of heartbeat evoked potential in the posterior cingulate. So in general, this was kind of a confirmation, first, that the default mode network anterior and posterior aspects may be centrally related to something about the experience of self related to thinking moment to moment, as well as the proposition really follows from their findings that something about the way that the brain is responding to our internal physiology, in this case the heart, on a moment-to-moment basis, is very much a part of this narrative experience of self as well. That they're not two different things, but kind of being encoded in some way that's related to each other. And another aspect of looking at self-related changes is from Olaf Blank's group. Over the last 20 years, they've been systematically looking at dramatic changes in self-experience, in particular the sense that the self can be experienced as outside of the body. One of their first papers was back in 2002 when they stimulated using some implanted electrodes a out-of-body experience by stimulating the right temporoparietal junction and stimulating a number of other areas on the right side of the brain did not lead to such an experience. This led them towards more and more fine-grained approaches towards stimulating experiences that involved some transformation of the sense of being in a body. And repeatedly, what they found was this temporoparietal junction to be of importance. Its activity changes in association with the sense that the sense of self is no longer so much located within the body. And it's a key node for multisensory integration of bodily signals, proprioception, interoception, sensory motor, etc. It's also one of the other nodes of the default mode network. So kind of zooming in on the real focus of this talk, the focus that studying self-related processes related to meditative practice may really be of value to understanding the impact of meditation on the brain and its relationship to human values and the benefits of these practices, is that it's also possible, of course, and now people are beginning to engage systematically with the approach of looking at the experience of self when engaged in meditative practice or as a result of engaging in meditative practice, and in particular looking to map the changes from the identification and experience of oneself as a kind of narrative self to more and more selfless modes, or modes in which the boundaries of self are relatively disintegrated. The most systematic and thoroughgoing approach to this kind of neurophenomenologic enterprise has been directed by Aviva Berkovich-Ohana and colleagues in Israel. And they have in particular conducted a number of studies with long-term meditators, essentially probing into the transition from narrative self-experience to a minimal self-experience, wherein there's a sense of an impersonal experiencing of moment-to-moment sensations. However, not the disintegration of the self-object boundary, and then that next level to the non-dual states, wherein, or selfless states, wherein the observing self disappears completely and experience is proceeding without a subject-object duality. What in some spiritual traditions is called one taste, just experience, just this. So in this enterprise, they have again made these contrasts across a few studies now, from the narrative self-experience, minimal self-experience, the selfless experience, considered to be the non-dual experience, and found these kinds of changes, in particular, the first investigation looking at long-term practitioners going through these experiences while having their brain recorded, showing that decreases in gamma activity in the anterior midline regions, both anterior cingulate and medial prefrontal cortex, seem to be characterizing the transition from the narrative self to a minimal self. And then at the same time, some decreases in beta activity in medial prefrontal cortical areas, subgenual, anterior cingulate, and posterior medial. So again, decreases in activity in the higher frequency range in some of these midline areas. And a second line of investigation, further fine-tuning their approach to getting at self-report, actually revealed that the right temporal parietal junction, the same junction that is known by work of Olaf Blank and colleagues to be very much related to the sense of being in a body, embodiment, was also a common locus of changed brain activity in association with the contrast going from narrative self to minimal self and all the way to the selfless experience, the dissociation of the subject-object duality. And so they replicated that in a group of 10, as well as a virtuoso, which to an even greater extent showed this dramatic reduction of beta activity that could be localized to temporal parietal junction area and surrounding kind of parietal. So another approach to looking at self-related processing is to stimulate the brain with external stimuli that are somehow self-related, and to compare that to stimuli that are not specifically self-related, and to see whether meditative practices can also specifically impact that manifestation of the brain's processing of self. A group in Germany, led by Stefan Schmidt and Matthias Trautwein and colleagues, found and published about 5 years ago the results of a paradigm wherein they presented subjects' own faces compared to other faces, and embedded those faces within a paradigm where they were responding to flowers with a button press, a target, and then regular presentations of a kind of scrambled image. And so the faces, both the self face and the other face, were distractors from the task of pressing the button every time a flower was shown. And what they found was that, in line with their hypothesis, the brain response in the P300 time range, when there's a kind of a conscious attentional, widespread attentional, attention-related response, it's around the 400 to 600 millisecond time range usually, that this amplitude was more different in controls, showing the expected extra amplitude to the self compared to another face, than it was in the meditators, where essentially it was just more similar. Still, as you can see in the figure, the meditators did have a bit larger amplitude of the P300 to self versus other, but the relative difference was certainly smaller, indicating that the meditators' brains somehow were not apportioning quite as much extra value or salience to the fact that it was either self versus other. And a similar kind of paradigm I want to talk about with regards to some of the work I've done and currently working on publishing. This is regarding the self-name paradigm. And the self-name paradigm is a paradigm that has really developed out of some initial findings that during wake, when you present recordings of somebody's own name compared to others' names, the brain seems to respond with this extra sense of importance. The P300 amplitude is greatly elevated to the self relative to other names. And it turned out, what became a real area of investigation is that even during sleep, the self-name evokes this extra processing, and it's kind of P300-like extra processing relative to other names. So it's been used as a probe to look into things like minimally conscious states or persistent vegetative states. Certainly, as you get into deeper and deeper states of sleep, the difference between self and other names brain response does diminish, but it doesn't go all the way. And in even some persistently vegetative states or coma-like states, there's still a little bit of this distinction that the brain is responding with that extra processing related to the self-name. And of course, the self-name is related to the self-narrative. It's a construct that we've come to associate with our sense of identity that lives in the realm of abstraction, and yet we have associated it as being so valuable as to have this kind of hardwired brain response even during sleep. So what we did is we used that self-name paradigm in the context of a oddball paradigm, and probed long-term meditators of different practice traditions relative to controls. And this is work that my colleague Arnaud Delorme and I set up at an ashram in India, the Swami Rama Sadaka Grama, and we had a number of collaborators, including Claire Baboge, who did her thesis work partly in association with this study that had a number of different elements. But this particular part of it, the self-name element, we have not yet published, and I'm presenting here the findings for one of the first times. We're just in the process, as I mentioned, of getting this published. So the full paradigm involved the presentation of a number of standard 500 hertz tones with occasional higher pitched tones that were targets or oddballs, and then these distracting white noise sounds and the self-name being played or another person's name being played. And the participants recorded their own voice saying their own name versus another name. And we presented the stimuli 3 separate times. First, while the participants were responding to the targets, and then 2 more times, once while they were meditating and once while they were thinking. And here is the response not to the self and other names, but just to the oddball stimuli that were targets in one of the active task condition. So you can see in blue the amplitude of the response to the targets when the participants were counting the stimuli. They didn't respond with a button press, but just instead internally keeping track and counting up the number of stimuli they heard. The amplitude was, of course, much greater than when the stimuli were presented with no conscious orientation of attention to them. And there's a well-known phenomenon that the P300 becomes much greater when you attend to something than when you ignore it. So what you can see there is that the meditator group in the dark blue compared to the light blue of the control actually had a bit larger amplitude to the target stimuli or the oddball stimuli during the counting condition. And in the two passive conditions of thinking and meditation, the amplitude was almost 0 in the meditator group, whereas the control group showed a little bit lower amplitude in the counting condition and a bit higher amplitude in the thinking and meditation conditions. And in general, this is statistically significant effect that the meditator group showed decreased amplitude during those passive states to these oddball tones, and statistically significant greater capacity to kind of go between a low to a high amplitude as they went from ignoring to attending to the stimuli. And this really reflects a rather well-known phenomenon now, that meditation does seem to be associated with a number of markers in enhanced attentional capacities or bandwidth, or the capacity to amplify the focus of attention in terms of its representation in the brain. But really the focus of this study was in this interesting distinction between these stimuli that were identical, other than the relative selfness of them, the name stimuli, which were presented as distractors. And the name stimuli, we can see demonstrated here, is the self name in the dark traces and the other name in the light traces. And so the control group, which was about 25, shows a much larger amplitude of P300 responding to the self name than to the other name, whereas the 3 meditative groups looked at together show basically the same amplitude of the other name as the controls, and no real significant increase of amplitude to the self name relative to the other name. And you can see that in the scalp plots, in addition to the ERP on the left. And the difference between self and other in the meditator group and the control group is demonstrated on the far right here, with the control showing the expected great increase of P300 amplitude to the self relative to the other, and the meditators not showing such an increase. And of specific interest here is that this effect that we saw in the controls is reproducing something that a number of investigators have found both in waking and even in sleeping states for many years. So really the unique thing here is that meditators don't seem to show the normal self-name effect that has been published, and seems to be true of the non-meditator brain, whether awake or asleep. The contrast looking here is the each of the meditator groups analyzed separately, about 20 participants in each group, just demonstrating that this was not specific to just one or the other of the groups, but was really true across all 3 groups. And the meditator groups, there's a much decreased differentiation in the brain's response to the self compared to other stimuli. And what these meditator group names here, just to flesh out the detail here a little bit, is that there's the control group on the top going from self to other, and then the self minus other. And then there's the HYT, which is the Himalayan Yoga tradition, one of the groups whose members actually had that particular ashram in Rishikesh, India as their kind of home base. The teacher there, Swami Veda Bharati, was a teacher of this tradition of Himalayan Yoga, and there are some certain similarity to some of the Tibetan Buddhist practices and what they practice in this Himalayan Yoga tradition. The ISY group is the Isha Yoga tradition, which is taught by a well-known teacher in India, South India. And at the bottom, the contrast is VIP for Vipassana. So these are Vipassana practitioners in the tradition of Goenka. So all three meditators groups showed this commonality, that there was no statistically significant difference between self and other responding, whereas there certainly was in the control group. And this is represented here in graphical format. Again, the self minus other name scalp map for controls versus the meditators averaged together, and showing here that this is a highly significant P less than 0.002 effect for controls, and P equals 0.7, no significant difference for meditators, and that this difference is equally true when looking at the groups individually. Each group, the p-value is 0.9 or higher, whereas with the for the three meditative groups, whereas with the controls, it was a highly significant decrease. This is one more graphical representation, or I should say, scalp map representation of the key self versus other responding, showing that not only was that finding true across the passive states in general, but specifically it was especially true in the meditation state. So controls in the meditation state showed this enhanced self versus other responding. In the thinking state, they also showed a self versus other responding that was significant. And the meditators showed no difference in either thinking or meditation states between self and other stimuli. One of the interesting implications here seems to be that for controls, attempting to meditate, which what they were doing is attending to their breath, doing a basic breath meditation. It seems that attending to the breath sensitizes the brain to being even more responsive to the self-stimuli than engaging in a mind-wandering exercise, which is what they did in their thinking state. But again, the meditators, regardless of whether thinking or meditating, just didn't show the distinction in their brains responding to self versus other. And the last thing I wanted to show about this study is that this responding of the brain to the self-stimuli, which has been, again, published as a basic finding in waking state in non-meditator groups, as well as repeatedly this finding of even during sleep, that there's this distinction between self-responding. What hasn't yet been published prior to this is whether there's any association with the amplitude of that self-name responding, that involuntary self-name responding, and any particular psychological dimensions. And what we saw in probing into that question is that the amplitude of the self-responding actually might be related to some interesting constructs. So both mindfulness, the greater the self-name responding, the lower the mindfulness scores, and in particular the non-judging aspect of mindfulness, that tendency to kind of judge our experience moment to moment, which is kind of maybe one of the most kind of self-narrative related aspects of mindfulness, is our judging kind of tendencies. And so of all of the dimensions of the 4 dimensions of the KIMS, Kentucky Inventory of Mindfulness Skills scale that we used to assess mindfulness with this cohort, it was the non-judging scale that was most highly correlated in this manner. And some measures of negative affect also showed a positive association. So the greater the involuntary kind of self-name responding, the greater the average negative emotion score on the positive and negative affect scale, the PANA scale. When looking at the average negative emotion, it was greater in those with greater self-named P300 amplitudes, and also the interpersonal reactivity, interpersonally reactive distress on the IRI also showed this association with, people who have tendency towards more distress related to hearing about how other people are, or observing how other people are doing, also showed greater self-named P300 amplitudes. So in regards to these findings, I propose that we have some reason to believe that presenting the self-name seems to be of some value in distinguishing the effects of meditation. In general, it leads to an activation of the attentional system, the P300, that is quite hardwired and present even during sleep, but doesn't seem to be present, at least in a awake state during looking at meditators. And this was found across 3 very different groups of long-term meditators, so it doesn't seem to be specific to one particular practice style of a more focused attention or more kind of engaged with mantra practice or what have you. The self-name paradigm may stimulate the self-schema in a way that's related to important domains of well-being, as one of the other kind of insights from these findings, the relationship between the amplitude of that self-name responding and it being inversely correlated with mindfulness and positively correlated with negative emotion. And overall, really, my take-home point that I want to deliver for the research community is that pursuing self-related neural markers and markers related to the relative involuntariness of the self-constructs, as well as probing into the changes in self-experience associated with engaging with meditation longitudinally, may give much better understanding of the relationship between meditation and the brain, given how centrally it is related to the objects of practice. So thank you very much, and I look forward to the discussion.